Hello viewers, you are welcome to this presentation. Today we are going to learn a new topics. What is the name of the topics? Name of the topics is Newton's laws of motion. So let's go with us one by one. This is the image of great scientist Sir Isaac Newton. So you know Sir Isaac Newton. So today we are discuss one by one Newton's laws of motion, inertia of rest, inertia of motion, as well as so many things. Aim of the lecture: if you learn this topic very carefully and attentively, you will able to know how the force act. The vital term of physics like Newton's laws of motion, inertia of the rest, inertia of the motion, and measurement of force. So stay with us. Sequence of the lecture: Newton's first law, Newton's second law, and we will discuss measurement of force. So Newton's laws of motion. At first we will discuss. Let me know Newton's first law. Everybody continues in the state of rest or uniform motion in a straight line until it is compelled by some impressed force to change that state. Newton's second law: the rate of change of momentum of a body is proportional to impressed force, and it takes place in the direction in which the force acts. Let elaborately we will discuss Newton's first law. Everybody continues in the state of rest or uniform motion. That means every body in this universe like this earth is moving, continuously moving. Or we are sitting. If you are sitting in a chair, your position is rest position. The table is in rest position, chair is in rest position, book is in rest position. So everybody continues in the state of rest or uniform motion in straight line or circular line until it is compelled by some impressed force. Without having external force, it will not change its state. That means it will be clear to you, if we will not produce any heat from the external agent, or will not heat to the body, it will remain same position. So clear it is. Next, Newton's second law: the rate of change of momentum of a body is proportional to the impressed force. That means the rate of change of momentum of a body. A body's momentum will change proportional to the impressed force. If force is increased, momentum will be increased. Actual word is that force, and it takes place in the direction in which the force acts. External force will make the direction. Newton's third law: everybody continues in the state of rest or uniform motion in a straight line until it is compelled by some impressed force to change that state. Okay. Rest: a body is said to be at rest position if it doesn't change or changes its position in respect of time and in respect of reference. Now it will be clear to you if I set an example. This building complex, a building is in rest position. Motion position: a body is said to be in motion if it changes its position in respect of time and in respect of reference. Moving bus, moving train, etc. Now, gentlemen, it is clear to you what is the motion. There are three kinds of motion. How many kinds of motion? There are three kinds of motion: translatory motion, rotatory motion, and translate-rotatory motion. So we will discuss slightly elaborate translatory motion. When the body is goes or move straight line, it is called translatory motion. Rotatory, for example, moving bus, moving car. Rotatory motion or x move or the direction of motion is x-axis, according to the x-axis. Rotatory motion, that means the body is moving circular way, that is rotatory motion. Translatory motion means in this motion make rotatory and translatory. That means here you find rotatory motion as well as translatory motion. That means the earth is moving around the sun. So it is clear. Now inertia of rest. A rest body is tries to be at rest or rest position due to its inertia of rest. Do you know what is inertia of rest? The property for which a rest body tries to be at rest is called the inertia of rest. Now I am giving you some example. When a man sit on a car and the car moves suddenly, the man get back. This is due to inertia of rest, because the lower part of the body moves with the moving car, but upper parts is in rest position. As a result, the man get back. Inertia of motion, the parameter for which a motion body tries to keep it in position is called motion position is called inertia of motion. For example, due to the inertia of motion, when we are sitting on a bus, running or running train or moving train, suddenly if the bus stop, what will be the situation? Upper part of our body turn backward, we may get pain. So due to inertia of motion, lower part of our body going together or with the bus or car or moving body, but upper portion is in rest position. But suddenly if break, upper portion going rest, lower portion going rest, but upper portion moving with the together. That is why this sort of accident may happen or occurrence. Newton's second law. The rate of change of momentum of a body is proportional to the impressed force, and it takes place the direction in which the forces act. Momentum is the product of mass and velocity. So mass, the total amount of a body in a matter. Velocity, the rate of change of displacement of a body, is called velocity. And force is such a kind of energy which makes a rest body to motion. On the other hand, it keep motion body in rest. Kinds of force. There are many kinds of force. So we'll discuss later. Let us measurement of force F equal to ma. Let us suppose that the initial and final velocity of a body, mass m, initial velocity u, and final velocity v. So the initial momentum of a body is mu and final momentum of a body is mv. Hence the change of momentum mv minus mu, the rate of change of momentum mv minus mu by t, where it is time. T is time, here T is time. According to Newton's second laws of motion, the rate of change of momentum is proportional to impressed force. Therefore, mv minus mu by t proportional F. F is impressed force, or mv minus mu by t equal to kt. M common, v minus u by t equal to kt. ma equal to kt, because v minus u by t equal to a, or acceleration. The rate of change of velocity is called acceleration. The constant k can be eliminated by choosing the unit force in such a way that it acting on a body of unit mass produce unit acceleration. Now putting m equal to 1, f equal to 1, k equal to 1, therefore f equal to ma. So gentlemen, thank you for watching this lecture, and if you like this lecture, please like, share and subscribe. Like, share and subscribe. Thank you all.